Hello, everyone. Thank you for mentioning the title of the talk, which is not shown, because my slides are not shown. Can you click some button here? Thank you. Yes. So yeah, it is actually for real. But I removed it because some people say like, yeah, but what does it mean for real? For real means that it has been used and lots of people using it, and I can explain what works, what doesn't work. For those who don't know what I'm doing, well, I'm doing different things related to Terraform since 2015, and so far everything is fine, despite OpenTofu, so let's don't talk about that one. But I like open source, and Terraform AWS modules started many years ago just because it was an interesting idea to make something what people can use, and now well, couple billion downloads from the registry, as far as I remember. So people are using it quite actively. Also, you may have heard about projects like pre-commit Terraform, which is also quite important for people who want to take care of Terraform configuration code, automatically update documentation, and so on. So yeah, if you want to have your code clean, please take a look into this pre-commit Terraform code. Today I will be talking about serverless, just because I still find this gap, there is pretty big gap when people want to spin up infrastructure and make it effectively using Terraform. They still struggle, and I feel that my job is to explain that enough struggle. Don't write your own cool things, because there are solutions, and I will try to show them to you. So yeah, hopefully you will learn something useful. Also, if you are learning Terraform and maybe you don't have enough experience, or you don't know what to do, please ask questions. And at the end of this talk, there will be a Q&A, and I will raffle a couple books, Terraform in Depth, which are very recent and they are very up to date. I have not written this book, so please don't think that I wrote any books physically. I wrote only a book which is called Terraform Best Practices, and I was lazy enough to publish it in paper because I think it's cool to have it online. So terraformbestpractices.com is my. This book, which is laying on my table, is not mine, but you can win it. So pay attention and ask questions, and everything will be fine. So there are a few places which I want to mention. Some of these places I started when COVID was, if you remember what COVID was. YouTube channel where I have a lot of interviews with creators and different Terraform-related subjects. And also I did quite a lot of live coding. So if you are into learning Terraform, I encourage you to subscribe and yeah, and learn something from there. Also, every Wednesday, actually it's today, and in 1.5 hours, there will be new newsletter about Terraform, what's new, different articles, different open source projects, which I find online, and I want you to subscribe. So, as I mentioned, Terraform AWS modules is a collection of more than 50 repositories. And just to understand kind of the scope, please raise your hand if you use any of these Terraform AWS modules or serverless, TF. Does anyone use it? Oh, good, good. So you can leave this room. There will be nothing new. But OK, no, actually, there will be some things new. I'm pretty sure that you will learn something. So the way I do is that I try to make everything open source. Well, OK, not try now, but I've been trying to leave from open source for a very long time. And there are a lot of people who support me. Some of these people are in this room, so thank you very much for that. And also, some companies find it very beneficial that community solve something, and then they use this code for their production load, and they don't need to think about it. So this is how open source work. Obviously, it's too perfect, and in reality, we still have to do some work, and sometimes you may sell your hours, but I really want to say big thanks to people who support me and who sponsor my work. At some point of time, approximately maybe a year ago, AWS realized that, oh yeah, there are people who use serverless TF, there are people who use Terraform, and people use serverless TF, which is just a collection of modules to manage and deploy and build serverless applications on AWS. So they started recommending this as one of the approaches, which finally, I would say, recognition after 4 years, which is really good. So what I want to talk about today is actually serverless architecture. I don't want to explain like what is serverless, because you probably have heard about it, and I'm not a big fan of explaining over and over the same things. So I really want to make this as useful for most of you as possible. So I will just explain basic things, then I will hopefully connect cursor, and I will show some code and maybe even execute it. And if it fails, then I will try to resolve it. That's pretty simple. Most importantly is that you guys have to ask questions, and if there is anything unclear, please let me know, and I can answer it. So sample serverless architecture looks something like this, right? Your user calls some API gateway, for example, and then API gateway talks to some services. Very simple. The cool part here is that we already have a definition of serverless. So serverless, at least that's the way I was thinking about it since very early days, is that I have to write my application code and focus on that. And essentially, Lambda is the main service where my application code will reside. And that was the whole idea. I've been writing software for pretty much most of my life. And I really like that I can continue doing that without thinking about the rest. So that was the whole premise of serverless, and I really like to think about this way still. Then at some point, we realized that, okay, in order to make everything the way it should be, we need to manage somehow our infrastructure. And as most of you are in this room, I believe you already use Terraform. If you don't, it's your second chance to leave this room. Okay, let's continue. Nobody left, so good. So we use Terraform to manage our traditional set of resources, and it was working fine. But then at some point, you realize that actually Terraform may be not a good fit to manage your Lambda functions. And I will explain it in more details why you may have think that this is not the best way. But I believe that it would be very effective if we use fewer tools and don't have to think about what is kind of resource we are talking about. Oh, this is like serverless resource, which is like Lambda. Then I need to use some specific things like AWS SAM or serverless framework. Or this is more traditional type of resource like VPC. Then I already use VPC module for that, and everything is that. So you have to think about what to do. I believe that it's much more convenient if you use one tool, which is Terraform, and you have everything there. So let me explain a couple of available options. Quite interestingly is that I made this slide, I think about 2 years ago, and during this period of time, there were no options which I want to add into this slide. So available options existed a long time ago. AWS pushed to us like default solution for serverless, which is AWS SAM, or another is serverless framework, or any type of CloudFormation flavor like CloudFormation or CDK, which is still available, and AWS or community tend to think that, okay, this is like default because it has serverless in the name, so I should be using that one. Then you realize that, okay, you also need to manage your infrastructure. And there are a lot of different options. I'm not going to list all of them, but you can imagine that there are plenty of options. And then you realize that, okay, you actually need to build this package of your, let's say, application and deploy it somehow. Again, there are even more options. Most common one is, of course, deploy.sh, right? Who doesn't use deploy.sh script to do the magic of deployment, right? Or makefile, or you may use some service like AWS Code Deploy, or you can script it any other way, the way you want. The thing is that now you have at least 3 groups of utilities which you need to somehow use, right? Some of them are a good example of like, okay, you describe your serverless infrastructure. Another group of tools is you manage this infrastructure. Then you perform some deployments. So it's a little bit too much, a lot of different permutation you can have. And quite obviously, if you use any of these approaches and try to go deep into any of these, like in my experience, serverless framework was the reason why I used to dive very deep and spend days just trying to understand how this plugin was written in serverless framework before I can become productive, before I can use it. So, and I'm not JavaScript developer, so suddenly I need to go very deep in understanding of serverless framework, like layout, or is this a bug, or is it a feature, or is it me who just don't know what's going on here? In most cases, it was a combination of all of this, but still, the point is that you essentially going to do a lot of yak shaving, and you will go very deep into things where you don't want to go. So 4 years ago, I realized that there should be a better way. What if we make these components for people to work with serverless tasks using Terraform? So we already know that Terraform has its own benefits. There is a Terraform provider for AWS, which supports a lot of resources and data sources, which we most likely don't have to ever look. Like if there is provider, then it probably works, or if it doesn't work, then you open issue and somebody else with more expertise will look into that. So that was very beneficial. And we already have pipelines. We already knew how to put changes into different environments. So that was very well-established path back then. Now it's even better because there are even more solutions available. Some of them are like Terraform automation services provided by either Terraform Cloud or OpenTofu competitors. The point is that there should be a way to build on top of something existing. And we just think, what does serverless actually means? And as a result of this, serverless TF is just a collection of absolutely decoupled modules which are suitable for all tasks related to building, packaging, and deploying, and so on. The most common one and the most popular one with lots of features is Lambda module. It currently supports all Lambda-related tasks. And I really like to think about all Lambda-related tasks, because as I said at the beginning, all Terraform AWS modules started with my own challenge. Like I work on some feature, or I work for some customer, and something was missing. So instead of making it hidden and upload it on GitLab behind 20 firewalls, I always tried to upload it on GitHub, even if it's semi-finished, like with Transit Gateway, which I will never ever finish. But in most cases, there are real use case. And if something is not working, it will be much better than, let's say, when many other people look into module or into problem, and somehow collectively we extend it. Now there are a lot of contributors. It's not just me. I'm not actually writing new features and new code for last many years, like right away. because there are a lot of people with small cases, and they add small pull requests here and there every day. So there are approximately 10 new pull requests and comments coming every day. So yeah, you can imagine that it's a lot of activities there. And the last serverless TF highlight, which is kind of important, is that I still want to believe that we use Terraform for everything else except application logic. So you still write your code into your favorite language, like all languages as well as all runtime are supported, and you use Terraform to put it into your infrastructure. It doesn't matter how you do it. You can run Terraform apply from your local machine or whatever. There are very, very few dependencies on that. So if you're still not convinced or not able to understand what is actually serverless TF, let me show this slide. So when you are trying to implement this very simple cross-service integration using plain Terraform, you would need at least this type of resources. So you can think API gateway has to have some resource, methods, integration, bunch of IAM properties, and this is not all resources, but a lot of them will have to be created for just API gateway. And a similar amount for Lambda function. You may have to create somehow Lambda package, and then you need to create Lambda function resource and some other IAM resources. You may have done this in the past, and you may look at this and say like, oh, but in my case is much smaller, so I will just need half of these resources. That's great. Maybe you can start with half of this resource, but eventually you will add it more and more. If you don't believe me, look into any Terraform AWS module, into source code, and try to understand why there are thousands of lines in each of these main TF files, because there are use cases. So with serverless TF, this implementation is significantly simpler. It's all just reduced to invocation of 2 Terraform modules. So one module is API gateway, and another module is Lambda function. And the connection between these 2 modules is happening on the route section of API gateway, where you just say that, okay, this route/customer should invoke this Lambda function. And Lambda function itself allows to be invoked from API gateway. That's pretty much it. So you can imagine that instead of writing 12 or 15 different resources, you can just write this piece of code and it will just work. That's, I find, very effective way of learning just what you need to know to get your job done. Of course, as all Terraform projects, they're open source, and if you want to extend it, or if you don't know what's happening or why this is happening this way, you can look into source code, or you can look into examples, and you will be able to understand much more. Also, serverless TF supports pretty much all serverless services. Yeah, and so we support, of course, like traditional set of services which you typically use, but we also fully compatible and fully supporting functionalities of traditional services like VPC and RDS, even though they are not typically looked as serverless services. We also support all possibilities to run and to package any runtime. We have shortcuts for Python with pip and poetry. We also have shortcuts for npm install, but there is also a possibility to do very large amount of features when it comes to building in Docker for different platforms, and many different ways to package, to create a package and control the deployment process. There are also examples for all of this in examples folders in each repository. And I know there are at least 2 people who are big fans of Rust, or maybe there are more people who like Rust. But this is a simple code which illustrates how to build package for Rust. It utilizes Cargo Lambda project, and it creates this package. And first it builds the package, and then it creates zip archive of it. And that's pretty much it. Like, as you can see, in order to build package, all you have to specify is like in which path you want to run certain commands. If this is not sufficient, you can always call your shell script, for example. Okay, so hopefully Cargo Lambda will continue to exist, and because people should use most efficient ways of runtimes, and for many cases, Rust is a very good solution. So if you want to learn more about integration patterns, there is another website where I think 1.5 years ago I contributed and I published these patterns and how to implement them using serverless TF solutions, which you can look and you can execute them, and you will be able to understand how it works. So if you want to learn more, go to serverlessland.com and then patterns and search for Terraform with modules. And another thing which I want to mention here is local testing and hot reloading. For those who want to have possibility to run Lambda functions, as well as pretty much the whole AWS environment on local machine or on some CI server, you can do this. You can use local stack. Localstack.cloud is URL. You can open account there, get token, and you will be able to run Terraform, but Terraform will not be token to real AWS account. Instead, it will be token to your local Docker setup, which it will provision for you. This is a very effective way in general to test a lot of things. If you don't want to spin up expensive services, or if you don't want to wait a lot, or if you want to put this into pipeline, or if you want to have it on developer machine, there are a bunch of different benefits. What I want to highlight is that local testing and hot reloading is a very effective way to combine Terraform configuration and hot reloading. Hot reloading means that you just change source code of your application, let's say your Python file, and you don't have to rebuild, repackage, redeploy. It will simply use something like soft links. So, and it will automatically recognize the change, and you can use AWS CLI to call this endpoint, and it will emulate as if it would be invocation to real AWS service. So it can be very helpful if you want to test output format or some other logic in your function. And yeah, it's very good feature to have. So yes, I have a demo and I still have some time. So let me share my screen. This is not my screen. No, I'm joking. No, this is what I want to show. So, no, it's good. No, this. So where is my screen? No, it's some space. Is it my screen? But it's dark. I don't see anything.
and display and not duplicate.
Yeah. Good luck to me. No. Okay, and display.
Duplicate.
Yeah.
Okay.
Yeah, much better. Okay, cool. So font size is okay. So what I want to show here is the way how it is configured. So as you can see in folder 2023, there are a bunch of Terraform files, and most interesting one is Lambda get and API gateway. So as you can see here, I'm just calling Terraform AWS module, specifying a few parameters, and specifying where my Lambda function is located. Also, I have possibility to specify, I think about 100 different parameters related to all aspects of Lambda function, like triggers, different policies, which has to be attached, and so on. So here I'm just calling policy statements, and I say that, okay, I'm allowing to read from this DynamoDB table, which is created by another module, and I allow this Lambda function to be executed from an API gateway. In API gateway, the configuration is similar. I'm just calling API gateway module, and I configure like required settings like domain name as well as routes. And DynamoDB is similar, so it's just invocation of DynamoDB table, Terraform module, and that's it. So when I run this code, well, it will work, believe me. No, it's pretty boring, I guess, to run it, but of course, if you want. Let's see. Yeah, at least we have internet. I think most interesting is this alias, which I'm kind of proud. So it's T instead of Terraform, all right? That's kind of cool. But okay, so if I run Terraform apply, it will propose to create 39 resources. A lot of these resources are about API gateway configuration, as well as creating certificate, creating Route 53 records, and so on, as well as DynamoDB and Lambda functions. So very straightforward. What happens here at the beginning, I just want to say briefly, there is an invocation to Python 3, and package is created. So package is created. It checks if there were changes in the source code, and if these changes has to be repackaged. If not, then it will reuse existing package. Everything is configured, but since I ran this earlier, it shouldn't take a lot of time. Now it will create a certificate and domain names and so on. So after that, it will be, it will be up and running. So yeah, I think I have a few minutes, and I think it's time to ask questions. So imagine that it works. Please ask questions, and again, if you ask good question, not about OpenTOF, okay? Then you will get this book. Yeah.
Here. So for Lambda function, for example, if I want to create the role of the Lambda function separately, because I want to add multiple policy statements there, when I define the integration with API gateway, will it then automatically detect the role, my role, and add a separate policy for API gateway, or how does that work?
Oops. Oh yeah. That's no. The thing, what you explain is behavior of AWS console, where you click something and then it says, oh, by the way, I will modify this permission for an API gateway, and I will do something for you, and good luck tracking it in your infrastructure as code. This will not happen here. You need to explicitly tell to add it in one place and in another place. Simply because this is how API works, not how AWS console works. So yeah, there is a way to specify, to control very precisely what and who can call and who can do in very different set of ways. Most of examples cover this functionality already. If you go to examples complete, you will see how these two things can be controlled, like API gateway and Lambda function is the most common pattern. It is possible to control this way. But no magic. If it's not in the code, then it doesn't exist. So that's really the whole idea. Yeah.
And the second one is regarding Terraform local. You mentioned that you have the option to do like hot deploys. So if you change the Lambda code, then the TF local module monitors that you changed it and it automatically deploys to local stack, or how does that work?
The way how it is implemented in local stack is very complicated to my mind. But from user point of view, it looks transparent. So it actually does not create package for you. It physically finds the location where this Lambda handler exists, and it physically calls it. So it doesn't package it, it doesn't provide IAM permission to Lambda function, though you can make it to respect. But by default, it's actually calling just Python or your runtime without packaging, without doing anything special. But the way how it is implemented is too complicated to my mind to even comprehend. Yeah. Thanks. This was good examples of good questions. Keep it up. We have 5 minutes and still.
So I would like to take a chance to ask you a question. So I understand that it could be a topic for a complete session, but it's very nice, for example, that we have modules that we have an opportunity to run and test it. But for example, what would be the strategy to deploy it to AWS? So for example, should we do code build or GitHub Actions? So what would be the preferred way just to like use it in some, I don't know, recommended way?
Well, a recommended way is probably not something what I can provide. Of course, I have opinions as on everything, but that's not something what I can recommend because running Terraform apply is not rocket science anymore. You can put it into GitHub Action if it works for you. You can put it into any existing CI process. Again, if it works for you, there are benefits in all of this. I see more and more people use it with GitHub Actions and run it continuously. I also find it very useful in some cases to rely on managed servers by some companies because there is sometimes a little bit more work to do than just running Terraform apply and hope that it works. So that's why there are some Terraform automation solutions exist. So my personal choice, most of my stuff runs on GitHub Action. That's, yeah, and including some production. Of course, when it runs in production and GitHub is down, I'm a little bit unhappy, but this doesn't happen so often. So, yeah.
Thank you for your presentation. I just have a question about the how you manage in your module the Lambda versioning and how you deploy different versions in different environments, such as development, testing, or production.
Yeah, that's really a good question and very big in itself. I can just try to open examples. So this is source code of Lambda module. And the way how typically I like to think about this is if you want to learn kind of about not best practice, I don't want to call it best practice anymore, But one of the ways how you can run Terraform and configure your environment so everything is more controllable, then look into TerraGrant or any other tool which stays on top of Terraform. Like I'm currently using TerraMate for most recent projects for last year, and I'm quite happy with it because it does the purpose. The main idea is that you split all of your environments, don't use workspaces ever, just have physical folders with different code. Then the task for you will be to run, pretty much to run Terraform pipeline in specific folder if you need to apply it on specific environment. Then you are happy with it. You do changes, similar changes, so you can automate it, of course. But you use the same version of the same module which you have just deployed to your dev environment and deploy it into staging environment, for example. So you don't try to save lines of code by obfuscating it. It doesn't make a lot of sense. Always try to make it separate folders, separate TerraGrant HCL files or any other Terraform configuration file, TF-vars, whatever you like. Really, it's very kind of irrelevant discussion, but use the same version of the module and try to deploy it automatically in one environment, test it there, and do the same changes in the environment, deploy it there, and if you're happy, do the same changes into production environment and deploy it, even on Friday. Yeah.
Last one. Okay. So out there.
Hey, Anton, thank you for the talk. Yeah, it's a long question. How do you approach testing of serverless resources defined with Terraform? And also, if you use static testing of the ESE code, or do you have a framework in mind to do the end-to-end testing of the deployed resources? Thank you.
Yeah, that's a really good question. And funny enough, I was thinking about this before GenAI became a thing, that one day there will be a tool, which is now called GenAI, which can help us with doing some tests. Well, it doesn't help. The tool exists, even AWS make it, but it doesn't work. So, I mean, the GenAI cannot write sophisticated tests to cover really deep and really big amount of permutation, which can happen in real life when users deploy these Terraform AWS modules. What I mean by that is that even AWS regions are different between themselves. So at some point, like 5 years ago, there were a lot of people who say like, oh, we need to have tests in Terraform AWS modules. Okay, good luck, write it. Then you write something for Happy Path, and then another region is being added, which does not have half of the functionality which is covered in the test. For example, it was a case, of course, it's not relevant anymore, which was Classic Link. Classic Link was not even present in Frankfurt when it was released, but our modules support Classic Link. So what kind of test we should write? For ancient regions, and then another test for new regions, and another one for future regions. Of course, we didn't do this. We are lazy. So we rely solely on execution by people in real environment and hope that they open issues at some point. So there is nothing else what can be automated. Wait. And there is also a Terra test which existed a long time ago, but I never wanted people to write code in Go to test HCL. Again, there is nothing wrong to create invocation in dev environment, test it for your cases, and say, okay, it works for me. Great, I'm happy that it works for you. But there is no way to generalize it for everyone else. So there will be no test for that. We can talk later because it's time, but you definitely deserve a book. That's.
I'm sorry to interrupting you, but you know, time is my boss.
Yeah,
so,
I know.
Thank you, Anton, and thank you, everybody. We have.
Yep.